Imagine peering back 13.5 billion years, when the first galaxies flickered to life in a dark, expanding cosmos. The James Webb Space Telescope has now delivered its first year of data, revealing infant galaxies at redshifts beyond 10 that challenge everything we thought we knew about cosmic dawn. In this video you'll see how JWST spots these ultra-distant gems, why their surprising brightness and mass force astronomers to rewrite formation models, and what these discoveries mean for the timeline of the universe's earliest light. Stick around to the end for a quick takeaway that could change how you view the night sky, and if you crave more deep space revelations, hit subscribe and ring the bell so you never miss a cosmic breakthrough. When the James Webb Space Telescope opened its golden eye to the cosmos, it did more than just take pictures, it opened a new window onto the infant universe. With a mirror over 6 meters wide and instruments tuned to the faint infrared glow of the earliest light, JWST can see farther back in time than any observatory before it, peering through cosmic dust to reveal the first stars and galaxies igniting just a few 100 million years after the Big Bang. In its first year of science operations, the telescope delivered a flood of discoveries that surpassed even the most optimistic expectations: galaxies that are surprisingly massive and mature, unexpected structures in the early cosmos, and hints of exotic physics that could reshape our understanding of how the universe built itself. Astronomers around the world watched as each new image arrived, their screens filling with ancient light that had traveled for over 13 billion years to reach us. The excitement was palpable, not just because we were seeing farther, but because we were finally able to ask questions that previous telescopes could only dream of answering. Each discovery feels like a piece of a cosmic puzzle falling into place, urging scientists to refine theories of star formation, dark matter, and galaxy evolution in the universe's earliest epochs. Now, let's step through that window and explore the galaxies born at cosmic dawn, uncovering the secrets of how the universe grew up. Just a few 100 million years after the Big Bang, the universe was still a dark, featureless sea of hydrogen and helium, waiting for the first lights to switch on. With its unprecedented infrared vision, the James Webb Space Telescope began to pierce that gloom, hunting for the faint glow of galaxies whose light has been stretched into wavelengths no ground-based observatory can see. By targeting blank patches of sky and stacking dozens of exposures, Webb's NIRCam instrument revealed tiny smudges of red that correspond to objects whose light has traveled more than 13 billion years to reach us. Spectroscopic follow-up with NIRSpec confirmed that these smudges sit at redshifts greater than 10, meaning we are seeing them as they were only 300 to 500 million years after cosmic birth. In these early galaxies, stars are already forming at furious rates, enriching their surroundings with the first heavy elements and beginning to reionize the surrounding intergalactic medium. Each detection is a snapshot of a universe learning how to build structure, and together they hint at a surprisingly rapid assembly of stars and galaxies in the infant cosmos. As we move from counting these primordial pinpricks to understanding what powers them, the next chapter will explore how their intense starbursts sculpted the first cosmic bubbles of ionized gas. These pioneering observations are rewriting textbooks on cosmic evolution, setting the stage for deeper dives into the physics of the first light. Building on the glimpse of infant galaxies that JWST gave us in its first months, the real surprise came when we measured just how bright, how massive, and how orderly these early systems appear. Their ultraviolet luminosities rival those of much later galaxies, implying they are churning out stars at rates that, according to standard models, should not be possible until the universe is at least a billion years older. Stellar masses derived from their spectra reach up to 100 billion times the mass of our Sun, placing them in the same weight class as mature spirals we see today, even though they formed when the cosmos was less than 5% of its current age. Perhaps most striking is their structure. High-resolution images reveal smooth disks, modest bulges, and even hints of spiral arms, features that theory predicts take many generations of mergers and slow gas accretion to build. Together, these three challenges, forcing us to rethink how quickly gas can cool, how efficiently stars can form, and how early dark matter halos can assemble, push the boundaries of our cosmological playbook. The tension between observation and expectation hints that we may be missing a key ingredient, perhaps a burst of primordial star formation or a different feedback loop, setting the stage for the next chapter where we hunt for the hidden physics that made these cosmic dawn giants possible. After a year of peering deeper than ever before, the James Webb Space Telescope has forced us to rewrite the opening chapter of cosmic history. The galaxies we thought only emerged a few 100 million years after the Big Bang are now appearing far earlier, their light stretched across 13 billion years of expanding space. This discovery does more than shift dates, it challenges the very models that describe how the first stars ignited, how their radiation reionized the primordial fog, and how dark matter scaffolding guided the assembly of structure. If star formation was already prolific at redshifts beyond 10, then the efficiency of early galaxy building must have been higher than simulations predict, or perhaps exotic physics such as early dark energy or modified gravity played a role in accelerating growth. Looking ahead, JWST's upcoming programs will map the spectra of these infant systems, measuring their metallicities, star formation rates, and the geometry of ionized bubbles around them. Simultaneously, wide-field surveys with the Roman Space Telescope and ground-based extra-meltly large telescopes will stitch together the statistical picture of how common these early giants truly are. Each new photon will tighten the constraints on cosmological parameters, potentially revealing tensions that point to new physics beyond the standard model. As we continue to listen to the universe's first whispers, the story of cosmic dawn is being rewritten in real time, inviting us to ask what other surprises lie hidden in the dark. In its first year, JWST revealed that massive galaxies were already forming just a few 100 million years after the Big Bang, pushing back the timeline of cosmic dawn and showing that star formation began far earlier than we thought. This discovery reshapes our understanding of how quickly the universe built its first structures and hints at even more surprises hidden in the deep fields. If you enjoyed this glimpse into the early universe, please hit the like button, subscribe for more space discoveries, and tell us in the comments, what aspect of these primordial galaxies fascinates you the most?